And Dev fans, and welcome back to the channel. Alright, so thank you so much for coming along on the journey. This is showing that nobody just wakes up as a LeetCode expert or, a 10x dev. We all have to try again to get things working as we expect them to. And, hopefully things compile at the end of the day. So in this video, I'm going to redo a problem I did earlier, which was the same tree problem. When I solved this problem, I noticed that all the cool kids were solving it in one loop or recursively. And all the cool kids, I mean, those people who show people how to do it online. So I decided to try to take 15 minutes to see if I could figure out how to do that too. So let's get to it. All right, so before doing that, I just want to do a quick run through to remind myself of the code for this. So if we do write it recursively, we'll need some base cases, and I think these are some good ones to start with. We also will continue to need like a traverse array of the visited queues. I guess that we could just keep one of them if the tree values are the same. Yeah, that's also true. And then I suppose that we could push the values in similar to here and run the function on the other values that we'd be encountering. Okay, and then to note, if we do use this recursively, the current function takes in only the root nodes p and q of the trees. Okay, so with that knowledge in mind, let's try figuring this out again. So this shows us the binary tree, how it's set up. This tells us what we're given as the inputs and that we're meant to return a Boolean. So, okay, what do we need to return true for? And how do we call this same tree thing again? So if whatever is given in, so p equals q equals null, like if all three of these things are null, return true. And then if p dot value is not equal to q dot value, return false. Okay, and then I suppose what is next? We need to send in both left nodes and both right nodes of both trees. So then we could say wait, but if we return a thing, then we don't need to do stuff. Okay, so if it's not null and the values are equal, then we'll go to the next step, which we're writing now. And what would we want it to do? We'd want it to say this same function, so is same tree on p's left value and q's left value, but comparing p's and q's left value, I should say, and comparing p and q's right value. So here, let's first compare is same tree for p dot left, and because since we send in here a p value and a q value, here we'd send in p dot left and q dot left, and then we said we do it for both left values and for both right values, and then is same tree p dot right and q dot right, and I just did like a control D replace there, which since we're in like a code editor that has that functionality similar to VS Code, helps return stuff a little faster. But yeah, since we are returning a Boolean at some point, if it returns all the way down, or if it runs through everything all the way down till where all the values are null, it'll give true, so like on a tree like this. But if it gets to a tree like this, where p's value does not equal q's value, then it will return. So also quick note that here it's val to match like this dot val. That's like what they send in. So let's try that out for style. Is same tree is not defined. That's weird. Because this looks like is same tree right here. Oh, I see. Is this because it is inside of solution? Yeah, so maybe kind of like when you're writing a problem and you have to do like this dot function, maybe here we have to do like, and I'm pressing Alt so I could try to type into both places at the same time. So yeah, solution dot is same tree because we're inside this class that they called solution. So let's try that. Nope, okay. That's interesting. All right, if anyone has any ideas in the chat, just me today? Okay, that's cool. We'll figure it out. Curious about sometimes the consoles let us see some of the background stuff that goes into how they use the problem, or like some of the code to see like how I could write or get my functions to work. But yeah, this is definitely typed the same as in just the words and stuff. Let's look it up. Oh, I wonder if it's that. No, but this has parentheses. Context? I've seen that before. Let's try it. Okay, okay. No return value. That's weird. Because it should return true. Interesting. Oh, it's not defined. Huh, that's funny. It's still doing the same thing. But, like, I don't think it was running before, was it? No? Okay, great. Love a tutorial. If condition, else recurse. Oops. Okay, well, if conditions. I mean, I could set it up as an if else block. Maybe I'll try that. Let's do this. And if you press Alt in multiple places, in most IDEs, you could type in like the same thing in multiple places. So that's what I was doing there. And then this one I'm going to turn into an else if. And then this one I'm going to turn into an else. And then Alt and the up arrow here to move the function and Alt-Shift-F to do a little fancy formatting magic here. Yeah, that is so interesting. It really does not like me trying to call the function. Okay. I'm going to look at the solution and see if I can figure out how and why it's working. Yeah, they use this. What? Did I talk about using this and not actually try it? That's funny. Okay. Yeah, so that's definitely what's going on there. Cannot read properties of null. Oh, interesting. Okay. So I guess if one of them is null, we can return false as well. Because this is if both of them are false. So else if, and then here. Oh, actually, maybe we could just put it in this case. If p.val isn't equal to q.val, or p.val equals null, or q.val equals null, return false. Yeah. So then let's try that. Nope. Interesting, interesting, interesting. Cannot read properties of null. That's interesting because, like, if p and q are null, we should just be returning true. And if one of them is null without the other one being null, we should be returning false. So it's saying that this is false because, or the program isn't running because it isn't reading these things. But why isn't it returning false? Okay, let's do some test cases here. Just send in some empty arrays and make sure it is returning false, or true, like we think it should. Yeah, they have this dot val, p dot val. Oh, maybe it's because here I'm saying p equals q equals null, but it should be p dot val equals q dot val equals null. Maybe that's what's going on. Haha, nope. Okay, interesting. Cannot read properties of null. Looking to read value. Let's console log these things. What's going on here? So they're both null. Okay. What if maybe it doesn't like that we have double equal signifiers? So like this is null and this is null? Try that on precise. Same thing. Weird. Okay, we're gonna go ahead and check back with the solution. The purpose of this isn't to get it perfectly great from memory. The purpose is to learn how to write these functions recursively. So that's what we're gonna try to do. If not this and not that, I wonder if this isn't the same as this. Oh man, okay. So there's three situations. If this is equal to itself, if p and q and p dot val is q dot val, return these things, sure. And if anything else, return false. But this is saying if p.val doesn't equal q.val, or one or the other is null. Okay, that's the same as them saying, oh, you know what I think is the problem? That this is just calling these functions without returning these functions. Okay. Oops. Yeah, because that way when it goes through, oh wait, no, we can't return multiple things. Oh, okay, they do it with the same thing in the same line. Interesting, because they both have to be true. That is true. Okay, I'll get some parentheses in there. Let's see what's going on. Okay, hey, 1 out of 3. We're getting closer. All right, good. So what is going on? And it's cool because I'm seeing the tables printing. Cannot read properties of null, reading val. Okay, so it doesn't like something I'm doing. Left null. Okay, so else if p.val and q.val is this. If this is same tree, this left and this right. I'm wondering why it's tripping over the fact that things are null, if that should be getting caught here. Yeah, so maybe I see why they're doing if not this. Because like that's if the values are null. But this is saying if not one or the other, which I'm also checking for, and the vowels are equal. Oh, okay, yeah, I'm checking if the vowels are not equal. Wait a minute. Are they returning false in this case? No. Sorry, I'm just trying to figure out what their code is saying. So let me step it through. Their code. So if there is no p and there is no q, if both values are null, return true, because that means we got to an edge, both of the trees are empty. Great. If there is a value for p and q, and the value of p and q are equal, then we recurse, aka return, the function called on the left and on the right. So I'm just going to go ahead and add to my notes that for recursive things, we are adding or calling the function again. Okay. So for recursive, code call this dot function sub problem inputs. Great. All right. So yeah, they're saying if there is a value for p and q, and the values are equal, then we recurse. So what I'm saying is that the opposite. If there is not a value, if the values are not equal to each other, or there is not a value in either of them, then we return false. They're saying p dot value equals q dot value, and these exist. And I'm saying if these do not exist, or these values, here's what I'm saying, they do not exist, and here I'm saying they do not equal each other. So I wonder, I'm seeing their difference as being the 3 equals versus the 2 equals. That is not it. Return p dot left, q dot left, and same and signs, this same tree, p dot right, q dot right. Wow, I do not know what is wrong with this code. Chat, anything? Okay, I'm gonna take a quick break and come back and give it another go in a few minutes. So thanks for tagging along here, and I'll see you soon. Okay, hello Team Try Again Dev. Looks like we're gonna try again today. Hopefully we are now older and a little bit wiser, more able to create a recursive function. Alright, thanks Geeks for Geeks. Looks like we're gonna be showing off how to troubleshoot a problem today. Looking for a true-false example. I mean, I get that, or I guess that this one is a true-false example. Just gonna make it so we can see the code a little better. Oh god, iterative depth first search. What does this even mean? Is the same tree while stack.length. We'll take the first two things off the stack, compare them. Okay. Breadth first search. Q. Yeah, two Qs. Oh wait, no, my answer was totally this one pretty much. Yeah, okay. I feel a lot better about the answer we came up with before then. Okay, so yeah, I'm just writing the recursive version because I need to practice with recursion. I don't think I ever even looked at the fact that my answer was literally one of the answers on here, so. Okay. Yeah. Alright, so what's going on here? We're seeing the two tree nodes, P and Q, which are the same. Oh, wait, no, maybe they're not the same. Yeah. Okay. It looks like I'm just returning false all the time, though. What is going on here? So we got to... Oh, okay. So since we're always console logging this is the second case where we had a null and a... Okay. What's going on is that we're diving into the case where, like here, okay. So in this example, the tree is like 4 null 7. So I think when we're at 4, we're pushing the null in as the next thing, and then wherever we're going into like q dot right, I guess, it's like falling into the null like whole void, whatever you want to call it. And so like the function isn't running, and that's why we're not returning anything. So I think that instead of p.val is null and q.val is null, what I'm gonna do is say like if p.left, wait, if these are null, if they're both null, return true. If p.val is not q.val, or, okay, I want to say if one of the children has a null value for the left or the right. So how do we write that? That would be if p.val or q.val or q.left equals null. But it didn't like when we did that in one step earlier. Maybe we could try it like this, p.left or p.left. And then over here, this could be right. So yeah, if only one of them has a child value, that is null. Let's try. This is so weird because to me, that should be hitting this case and returning true. I guess, I wonder if this would have to be P and Q instead of P dot val and Q dot val. Okay, 2/3 of the way there. We're making progress. Love to see it. Now what's going on here? Yeah, this is such a weird one. So what I'm expecting it to happen is, well, we know our false case works. Okay, well, if this is an OR operator, I think it would only return the thing that is the not null one. Okay. So then in here, what I'm gonna do is just say if any of these are null and do it like manually the written out way. So let me start from here. Let me copy and paste the equals null. So it's like 4 cases. So like if this or this or this or this or this, return false. And like, okay, great. I'm just super glad that it left it this way so it makes it a little easier to see, kind of. Yeah, I think this is what I wanted to say now and how I wanted to say it. Okay. Alrighty. What is the problem now? Ooh, I'm returning null when something thinks it should be true. Hmm. It's like funny because it's like the base test case that I would have had here generally. Ooh, I can actually add an extra test case. I do keep having the oh, maybe not. Okay, I guess not. I would love to have it have the empty test case as well, but I guess that's not possible. Okay, so something in here is returning false when it should not be. So, okay, I think it's that when we're iterating through like these lower values, both left and right are null. I'm seeing why they did it the other way, because like getting into all the cases is indeed bloating the code a bit, but how do I want to do this? Because I want to say if p dot left is null or p dot right is null and they don't equal each other. So that's this. And then you could add some more parentheses and say, and p dot left is not equal to q dot left. Okay, and that's essentially one case. And then we'll put this all on one line for readability. Similar thing here. We add oh wait, yeah. We add a parentheses here. Add a parentheses here. Add a parentheses here. And here we get to say and p dot right is not equal to q dot right. Then we return false. Good gracious. Great Scott. Great googly moogly. Okay. Darn. That's really interesting. Yeah, so I guess what if one of them doesn't have a value? I guess we could put those cases in here too. If they just don't exist, let's try. Oh god. Q is not a function. This is such an interesting case to write tests for. Okay. Oh my god, yes. It says accepted over here, so I'm just like making sure. Yeah, there we go. Okay, we wrote that recursively. Go team. All right. Well, looks like I'm here alone again, but thank you for watching. If you are watching on YouTube after the fact, yeah, keep tuning in to Try Again Dev, where if at first we don't succeed, we think about why we didn't succeed, adapt, and overcome, or try to. And if we don't overcome, then we try again, and we try again with adapting, adjusting, and overcoming, eventually, hopefully. So see you next time.